Welcome back after the break. It's my pleasure to introduce our next speaker, Tomasz Konieczny, a QA lead from Testkube. And what is he gonna talk about? Obviously, testing. Let's give him some warm welcome. The stage's yours.
Hello, it's really great to be here today at KCD. And I'm Tomasz Konieczny, career at Testkube, and I will tell you today a bit about testing and cloud native. As you know really well, cloud native changed everything at every single level. I mean, transition from monoliths to microservices, VMs to containers, static infrastructure to ephemeral environments, and also from manual operations to GitOps and automation. Linear releases, progressive delivery, all of these things around. But it also means that QA and testing needs to adapt accordingly. Because you need to shift left, I mean, start testing earlier in the process, often before any code is even implemented on the requirements phase. But you can also, or you should also, shift right and still keep testing even after application is already deployed and released. But at the same time, you need to care about this middle part, so basically testing everywhere. What is continuous testing? It's basically the continuous validation in automated way at every single phase of the software development lifecycle, triggered automatically by events. It may be code, it may be infrastructure, it may be pipelines, with observability, so basically visibility of what's happening everywhere. So results, logs, artifacts, metrics, analytics, all of these things that may be needed. And basically enforcing quality gates. So it's not only about simple automation of activities or flows, it's more like automating complete workflows and making sure it's actually enforced. Testing everywhere, I mean, with all of these pipelines, all of these environments, I mean, staging, production, ephemeral environments, all of these things with different testing tools, with different triggers and all of these rules, it can quickly result in complexity. And it can quickly get out of control. Test sprawl, I mean, very different testing tools that may require custom approaches, fragmented environments, dev, staging, production, ephemeral, all of these with different rule sets, with different requirements. CI/CD bottlenecks, I mean, the single long-lasting test shouldn't stack your workflow, your release, and also lack of observability. So basically, not being able to define what exactly happened, not being able to debug it properly, not being able to understand what exactly happened there. Wasted compute resources. I mean, it's really easy to over-provision things, especially with very different providers. If we have a separate provider for different testing tools, for different workflows, for different things, it's really easy to over-provision. Inconsistent practices, well, that's the common one for companies where there are multiple teams. I mean, every single team can approach things differently, and their approach is always the one that's the best. It can quickly result in inconsistent things. I mean, reinventing everything from scratch again and again, which is really time-consuming. And the result of this is also often a complete chaos. I mean, it's really simple to end up with this. Wouldn't it be nice if you could just launch any test with any testing tool at any environment whenever you need it, and everyone was on a single platform for running, scheduling, and monitoring, with your existing infrastructure where you can actually orchestrate these things without additional providers. You could do everything on-prem with unification, because that's the really common problem. I mean, I can have a single project with end-to-end tests, with performance tests, with, for example, Postman, K6, Cypress, Playwright, whatever, all of these combined often. And it's sometimes useful to just have some kind of unification. And today I will show you how to simplify some of these things in Kubernetes native way with Testkube. What is Testkube? It's basically the test orchestration tool for Kubernetes. It abstracts away the testing part, and you can still use Kubernetes and your existing infrastructure, your existing clusters. And Testkube consists of a few different components, but it basically introduces the concept of test workflows with abstraction that's focused specifically on tests, providing observability, providing analytics, providing execution engine, and all of these things around. The first thing is control plane, so that's basically the work orchestrator, dashboard, user management, scheduling, all of these things. And the second component is basically the runner, so that's something that you deploy on your cluster that manages the whole execution process with Kubernetes. So everything ends up as Kubernetes jobs in the end. But Testkube also provides CRDs for common things like test workflows for managing the test execution. So you can version everything in a GitOps-friendly way. So for example, you have your tests in the repository, you can extend them with workflows. So specific instructions how to execute these for different environments, for different cases. I will go through specific examples later, but we have types for test workflow, for templates, which allow you to abstract away commonly used things, test triggers, so basically for reacting for things or events happening on the cluster side, so it tracks the state and reacts on it, webhooks for external integration, and all of these things around. Workflows, that's basically something test specific, because I mean, you could run anything as Kubernetes jobs, but tests are a bit specific. I mean, for different testing tools, you would have some common things like checking out from a Git repository, running these things, downloading images, all of these standard things. And test workflows basically allow you to simplify some of them. Let's start with examples, because that's something that you've been waiting for until now, definitely. So let's start with something simple, a Postman collection, because there is definitely a case you might have in your project. I mean, it's quite common to use Postman or similar tools for testing basic API responses. And the workflow starts with the type, I mean test workflow type, metadata, so standard Kubernetes things, I would say name, let's name it Postman workflow smoke. That's the example directly for our test that we use internally for testing Testkube. Labels, so again, it's useful to have things labeled, in this case, two labels that allow us to easily identify these things. And then the actual part of the workflow, so spec content are the instructions of how to get this tests. So in this case, it's Git repository, so that's one of the sources. URI, that's main Testkube repo in this case. It's publicly available, so you can check it there. Revision main, and path is just the path for this specific Postman collection. You can check everything there in the test directory. Container, so these are global settings for the execution. So in this case, it's just Postman human image. Container resource request, so it's possible to pass anything to the Kubernetes job. And in this case, it's needed to have the proper auto-scaling. Job, active deadline seconds, it's usually useful to have some timeouts configured. And then the actual steps, so that's something that will be executed. So in this case, it's just a single run test step with the shell command, so pretty simple human run CLI. So that's the first workflow. We could just apply it with kubectl apply -f. Let's name this file postman YAML, and it's created. You can then use the CLI to just run it with testkube run test workflow, or this shortcut here, the name of the workflow, and it would work this way. But it's often useful to handle things in more convenient way. I mean, internally we use Argo for handling all of our definitions. We will do it the same way here. So here is the directory structure of the test directory in Testkube project. I removed some of it anyway because there is a lot of things here. So here we have the directory structure with very different testing tools. All of these directories contain example projects, like for example, example Cypress project, Playwright, JUnit, JMeter, all of these things. And they also contain the definitions for test workflows, how to execute these things. And we version everything, we synchronize everything with Argo, depending on environment, with different triggers. I will also show you triggers later. But let's check what's there, something more complex than this Postman example. Let's run some Playwright tests. The beginning is similar, I mean, just the name, labels, spec content, again, getting things from the same Git repository. This time the directory, not the file. container, this time a playwright container, different resource requests, because it's a bit more compute intense. Working directory, it's possible to set it globally, which makes it easier for the steps. Job active deadline second, so that's the timeout, and then the actual steps. So npm CI to install the dependencies, then the actual test step for running the tests. And here you can see that there is not only the shell command, but also custom ends that are passed to generate specific reports. Nothing unusual. The artifacts part is what's quite useful here, because it will allow you to store any artifacts generated by your testing tool, which is really common thing across different testing tools. And in this case, all of them will be saved, all of them will be parsed, and as long as you provide the JUnit report, which can be enabled, for example, here for the playwright, you will also have this parsed with more human-readable way. Syncing with Argo, that's how we handle it internally, at least, because we have like 250 different workflows across different environments. We execute them completely differently with different rules. We just use Argo with specific triggers. And this Argo application is quite simple here. It's basically just the source with the directory pointing to the definitions. So basically we sync the whole test directory with just some excludes, and we apply every single workflow at any environment with very different triggers. So triggers are separated. It can be a separate workflow, which I will show later. But Argo also adds these Argo labels, which make things more visible. They allow also additional filtering, which may be useful while managing things. Let's run some tests, this time in the dashboard, so we can check how it looks like after this workflow is executed. So basically you have all of the steps here, you have the basic logs. On top of it, you can have JUnit reports that provide you full insights of what's happening there. So it's not just the log, but also something that's really important for QAs or people that are usually using these testing tools. QAs, developers, I mean, it really depends on the tool. But as long as the testing tool creates the JUnit report, which is quite common, then we can parse it, and it's clearly visible what's happening there inside. In addition to that, there are artifacts which are also served. So in this case, it's possible to view them directly as reports or even dynamic ones like playwright traces, these kind of things. We have resource usage because it's really important to have the resource request set for something that's scheduled in Kubernetes, because otherwise it won't auto-scale correctly without knowing the expected resources. So in this case, resource usage allows you to check what's actually happening there during the execution, what's the resource usage, and adjust things accordingly. Services, that's one of the features that allow you to start something before the actual test execution. So it may be, like in this case, Nginx, for example, for just a simple curl test. It may be something more complex. I mean, it may be some simple application. You can run it with services. So spec services, then the name of the service, image, props that are optional, and after it will start, as you can see in the screenshot below, then the actual test execution will be started. Then everything will be cleaned up after it. So here you have just a single step that runs curl and checks if this deployment is correct. Parallel step is something quite useful for QAs, especially because they usually run the high-level tests. So for example, some playwright or Cypress tests can take like half an hour, and it's quite useful to parallelize these kind of things, especially with Kubernetes, if we can manage this load dynamically. And here we will have an additional structure, so spec-config, where you can pass additional parameters to the execution. It supports ints, it supports strings, depending on your need. And in this case, it's K6 example. So in this case, we will just run multiple K6 runners with specified virtual users, duration, and also here we have number of workers. So we will run by default 2 workers unless specified differently. The whole template can be parameterized here, so you can then use this parallel for handling parallelization of the step, count number of workers, pass from the config file, so everything is here possible to be parameterized. You can use templates. You also have the predefined variables, like for example, number of parallel runner that has been executing, and things like that. Post true. This one is quite interesting because it allows you to sync the execution. So if you want to start, for example, 10 different runners or workers, it prevents it from executing in different times, so it will wait for all of them to start. Then, if everything is ready, it will start the execution, which is pretty important for load generation because you want to usually generate it at the same time. So that's the post, and also here you have the template because workflows allow templating things. So you can abstract away some part of the workflow that's reusable in some way. So for example, users often abstract away checking out the test from the Git repository because that's the often reusable part, or some specific steps. I will show you more complex examples later. Workflows can be combined. I mean, it's possible to build workflow suites, even if it's internally just a workflow. There is an execute keyword that allows you to execute other workflows on the step level. So in this case, here is our internal playwright workflow suite, which contains very different playwright scenarios, because we have some separate tests for playwright with different variants, like for example, standard one with command and args instead of shell, with template, with some JUnit report, with distributed version. All of these things combined, and we want to have the visibility. So we built workflow suite, added some labels that allow us filtering this easily, and then we can control the execution. So in this case, we execute in parallel, but limit with the parallelism of 2. So everything won't be executed right away at the same time, but it will be scheduled dynamically up to this allowed limit. It's possible to mix any of these, so it's possible to use the standard step, then execute some other workflows in parallel, and then again run the standard test. So it's possible to mix them quite a lot and build exactly what's needed. Here is our internal set of workflow suites, because basically we support some of the testing tools that are popular in any way, like Artillery, Curl, Cypress, JMeter, Playwright, all of these. And we have dedicated suites for all of these. On top of these, we have something like full suite that contains everything. So here you have the example of this full suite. It again triggers workflows, but that's not just the standard workflow, that's the workflow suite. So you can have multiple levels and you can nest it further to have visibility on every level. So starting from the highest level, you can see if everything passed, but then you can go and still have this granularity. Triggering task workflows. I mean, that's something really common to do. I mean, you can use manual triggers. I mean, you can use CLI, you can use dashboard. Cron triggers are still something that's used quite commonly. So here you have an example of the cron trigger that triggers it twice a day. Just a simple workflow in this case that just executes another workflow. So that's how we approach it at our environments. We have the workflow separated, we have the logic separated, and then we have separate trigger workflows that manage only this part. So then we can apply this based on environment, based on the case, to achieve exactly what we need. It's possible to trigger it from the pipelines with CLI, with, for example, Algo prior posting hooks. But it's also possible to trigger by cluster events. So in this case, it's an example from our dev environment. We trigger the small suite after a dev application is deployed. So in this case, we have the selector, so that's the resource selector that matches by label. So in this case, deployment with specific name at specific namespace. And based on that, we can do some actions. So if it's modified, we run workflow with specific test selector. It can be specific workflow or suite like in this case, or it can be label selector. So depending on what you need here, it's possible to trigger by resource, by group, by whatever, resulting in some workflow or group of workflows being scheduled. So that would be all. If you would have any questions, I'm here, or you can also come to the Testkube booth and we can talk there. So thank you.
If you have any questions, I can lend you a mic.
Yeah, hello. Thank you for the presentation. It was really informative. My question is, in our project, we are using chainsaw tests in the cluster. My question gonna be, like, this Testkube is more like chainsaw, not like kind cluster, right? Am I correct about
So Testkube basically is an abstraction over Kubernetes jobs. So in the end, it ends up in a Kubernetes job. You can even pass things directly, like resource requests or labels or affinity or whatever you need. You can pass it directly to the job.
But I need to create clusters separately by myself.
Yeah, you need to have your cluster already in place. Where that's where you install the Testkube runner, which can then handle the execution. It uses Kubernetes for scheduling everything, so it's just an abstraction over it. With abstraction like workflows, which make it just easier to handle things, specifically for test-related things, plus some additional things like dashboard and all of these things. But in general, it's an I would say abstraction over Kubernetes types, because everything ends up in the Kubernetes job.
Understood. Thank you.
Any more questions? I don't see any hands raised. So once again, warm shout out to our speaker, and thank you for your talk.
Thank you.
A little bit of housekeeping. We have a longer break now. The next session starts at 3 p.m. So enjoy your coffee, snacks, and hallway discussions.